How many of these do you see every day? Cars, vans, jeeps, trucks, the list is endless. My name's Valerie and I'm the Outreach Coordinator for Future Energy Systems, or FES. FES is a research program at the University of Alberta focused on studying the energy transition. Thank you so much for joining us to learn about cars today. In this series of clips, we're going to learn about efficiency, build a car with some at-home materials, and if you want to stick around longer, meet a researcher who is looking at ways to reduce the environmental impact of cars. Here you're going to meet some of the members of the University of Alberta EcoCar team, and they're going to explore efficiency with you, what it is and why it matters. Then they'll guide you through an experiment where you can test it yourself. Here are the supplies you'll need. Time to buckle up.
Hi everyone. Have you ever heard the term efficiency and wondered what that meant? In this video, we will explain to you what efficiency means, why it's important, and an experiment you can do to understand efficiency with just your household items. First, some introductions. We are the University of Alberta EcoCar team. My name is Willow, the project manager of EcoCar, and with me we have Anita from the mechanical team and Jade from the fuel cell team. So, what does EcoCar do? We are a team of undergraduate students at the U of A who work together to design and build hydrogen fuel cell powered cars. These cars might look like a normal vehicle you would see on the road or on a racetrack, but there's something special about them. They don't have an engine like most cars do. Instead, they get power to drive from something called a fuel cell, which I will explain a little more in depth later in this video. So the next big question is, why do we do it? You may have heard a lot about something called sustainability from school or on the news. Sustainability is the idea that the technology we use now shouldn't be harming our planet for the future. Unfortunately, cars and trucks that we use nowadays contribute to negative effects on the environment, such as air pollution and global warming. Transportation is the largest source of carbon dioxide emissions in North America. Carbon dioxide, or CO2, is a small molecule that is emitted when fuels like gasoline are burned and acts as what's called a greenhouse gas to contribute to global warming. Fuel cell cars like ours emit no air pollution and no carbon dioxide, so if everyone drove a fuel cell car, we would emit less greenhouse gas. In EcoCar, we believe that fuel cell vehicles will play an important role in building a more sustainable future, which is why our motto is, building the future, one fuel cell vehicle at a time. Our team is made of students studying all different kinds of engineering, as well as business. We are organized into three main teams. The mechanical team designs and builds the physical systems of the car, like the shell and the chassis. The electrical system team makes sure that electricity gets from the fuel cell to the motor in order to drive the car, and also builds systems such as headlights. The fuel cell team makes sure the fuel cell runs in order to produce the energy our car needs. So, what exactly is a fuel cell? A fuel cell is a lot like a battery, but you never have to recharge it. It takes hydrogen on one side, called the anode, and oxygen from the air on the other side, called the cathode. The cathode and the anode are separated by a barrier called a membrane. There, an electrochemical reaction takes place, which takes two hydrogen and one oxygen molecule and turns it into H2O, which is water. This reaction generates electricity, which then goes on to power the car. The only byproduct is a tiny bit of water, which is safe to release into the environment. As well as emitting no carbon dioxide, fuel cells are also great because they are very efficient. On that note, what is efficiency? Simply put, efficiency is a ratio of how much energy you need to put into a system compared to the useful energy you get out of the system. In a heater, for example, you put in electrical energy and you get heat energy out. So the efficiency is the amount of thermal energy from the heater divided by the amount of electrical energy you put into the heater. Now let's take a look at an activity you can do at home to see what efficiency is for yourself.
Hello, today we're going to be testing 3 methods to propel a car to see which one is the most efficient. The methods we're going to be testing are a balloon, an elastic, and a ramp. You will need balloons, elastics, books, and one car of your choice. We're using Hot Wheels, but you can use a car made of Lego or anything else. Measuring tape and some tape. Dogs to help with the experiment are optional. To start, write down your prediction in the worksheet of which method you think will be the most efficient. The first method we're going to be testing is the balloon. Mark the starting point on the ground with a sticky note or your ruler or some paper. Blow up your balloon. You might need someone to help you with this part. Pinch the end of the balloon to stop the air getting out and attach it to the car with a little bit of tape. Then line the car up at the starting point and let it go. Once the car stops, measure the distance from the starting point to where it stops and write the distance in the worksheet. Next, we're going to propel the car with an elastic to slingshot it. Line up the car at the starting line and loop the elastic around your fingers like this. And pull the elastic back with your other hand. Line up the elastic with the back of the car so when you let it go, it will hit the car and release your finger. Same as before, measure the distance from the starting point to the car and write it in the worksheet. The last method will be to propel the car with a ramp, just like a slide for your car. For my ramp, I'm using 2 thick books stacked up and another book on top at an angle to the ground, but you're welcome to be creative and use whatever materials or design you'd like. Put the car at the top of the ramp and let it go. And then measure the distance the car traveled and write it in the worksheet. My car went so far that I had to get a different measuring tape because mine wasn't long enough. Which method made your car go the farthest? For me it was the ramp, but it might have been different for you. If your balloon was smaller or bigger, you had a different elastic, or had a lower or higher ramp. As you learned earlier from Willow, efficiency is a ratio of how much energy you need to put into a system compared to the useful energy you get out. According to the law of conservation of energy, the total amount of energy is conserved. Energy never disappears. It just changes to another form, and some energy transfers are more efficient than others. In this case, the useful energy that moves the car forward is called kinetic energy. The balloon, elastic, and ramp all have potential energy. When we are trying to figure out which method was the most efficient, we have to look at how far the car went and how much energy it used. Methods can be less efficient if energy is lost to something that doesn't propel the car forward, like the balloon spinning the car around in circles, or even the elastic making a sound when it snaps. That's lost energy. The balloon wasn't very efficient because it took a lot of energy to blow it up, and it didn't go very far. The elastic was less work and the car went farther, but the ramp was the least amount of work and the car went the farthest, so the ramp is the most efficient. Next, Anita will be talking about how we design our car to be really efficient.
When you're trying to build the most efficient vehicle possible, there are more things to consider than just your energy source. You can design both the internal and external components of your car to be as efficient as possible. When you're designing for efficiency, the simplest parts to consider are the weight and aerodynamics of your vehicle. The more your car weighs, the more energy you need to propel it forward. Less weight means less energy needed to move the car. Because of this, you need to consider the weight of your car when you're designing components such as the shell, chassis, and suspension. Of course, if you want to, you can design a car to be an indestructible brick made of pure steel, but that would weigh thousands of pounds and be extremely inefficient. Instead, you can make components of your car out of lighter materials, such as making the shell of your car out of carbon fiber, or choosing less dense metals like aluminum. The second thing to consider when designing a vehicle is aerodynamics. For a car, there are 2 main forces you need to consider. Drag is the force acting in the opposite direction to the motion of the car, while thrust is the force propelling the vehicle forward. For us, this force is generated by the hydrogen fuel cell. On the mechanical team, the main force we concern ourselves with is drag, and a lot of what we do is coming up with ideas to limit it. From the drag equation, we can see that it is directly proportional to the speed, the drag coefficient, and the frontal area. To start off with speed, you can see that drag will exponentially increase the faster you go. Because of this exponential increase, Speed is the main factor in determining drag. At low speeds, drag will not have much of an effect on your car. In the early 20th century, cars were designed like bricks, as seen in the photo on this slide. Their top speeds were around 30 miles per hour. They did not need to be designed like a sports car since drag would not have much of an effect on them. Our car also has a top speed of around 30 to 50 kilometers an hour, so drag even for us is not that much of an issue. However, when you're trying to build the most efficient vehicle possible, everything matters. The drag coefficient is dependent on a variety of factors, the main ones being the shape of your car, the smoothness of the surface, and your speed. For example, a cube or a truck will have a drag coefficient of 1, while a teardrop shape will have a drag coefficient of around 0.04. For the frontal area part of the drag equation, it basically means that the smaller the surface area of the car means that there's less material for the air to push against. This results in less drag. For us, we mainly look at limiting the drag coefficient and frontal area of our car. We personally have achieved a lower drag force by designing an aerodynamic outer shell that is also smooth and sleek.
Thanks, Anita. So to summarize this video, efficiency is the ratio of energy that is input to a system to the energy output of the system. Fuel cells are very efficient and emit no greenhouse gases, which is what makes them great for our team. On EcoCar, we design efficiently by making our car light and aerodynamic. Thanks everyone for watching, and we hope you learned something about efficiency.
What was more efficient for you? The balloon, ramp, elastic? Feel free to share with us on social media. And did you have any pets stop by too? In this part, Leslie is going to guide you through how to make a car powered by a balloon. Here are the supplies you'll need. Have fun!
Hi everyone, my name is Leslie and today I'm going to teach you how to build your own balloon-powered car. So for the experiment today, here's what you're going to need. A balloon, 4 plastic water bottle caps with a hole poked in the very center. You're going to need 3 straws, 2 skinny ones and 1 fatter straw, some tape, 2 skewers, an elastic, and a plastic water bottle. So to start off, we're going to build our wheel and axle. The skewers are going to act as the axle, and the bottle caps will act as the wheel. So after you have the little hole poked in the center of your bottle cap, you're going to stick the skewers, or stick one through the skewer. So now I have a wheel on one end of the axle, and the next thing you're going to do is take your little straw and stick it through, and then put the wheel on the other side. So after you're finished, it should look something like this. Make sure that the straw can freely move in the center, and you're free to cut off these ends of the skewer if you want. And do the same thing with the other one. And these are your wheel and axles, and we'll set that aside for now. So next, we're going to find a way to power the car, and we'll do that using the balloon. So the balloon will essentially act as the car's fuel. When you blow it up and let it go, the air shooting out of it will propel your car forward. So with your fatter straw, you're gonna put your balloon over one end of it, like this, and then you're gonna secure it with an elastic band and tape. Just make sure that you can blow the balloon up from this side of the straw. And just like that, your balloon should be secure. You can double check it by trying to blow it up. So that's good. And then you can set that aside. All right, so now we have all the parts of our car ready. We have the body, the fuel source, and the wheel and axle. And we just have to find a way to attach all of this. So pick up the body of your car and have the open end as the back. So we're gonna put this guy on the top of this and tape it down. So remember that when you blow into this, the air is gonna come out this way so that your car will go this way. And it should look like this after. So once your balloon is attached, we can start attaching the wheel and the axles. So directly on the other side of this, we're gonna put the wheel and axle. And so do the same thing that you did with this and tape these guys on, but tape it over the straw. And your finished product should look like this. All right, are we ready to test them out? So, blow up your balloon and then place your finger over the end of the straw so that no air can escape. Just like that. Alright, now you guys have built your own car. So in this video, I've shown you the most basic way to build the car, but you can definitely play around with having a bigger water bottle, having shorter wheels, or doing anything to modify this car to see if you can get it to go faster and farther. Thanks guys, I hope you enjoyed.
How did your balloon-powered car turn out? Feel free to share any pictures or videos on Future Energy Systems Twitter or Facebook. In this final part, we are going to meet another researcher, Yu Hao Hung, who is studying how to reduce the environmental impact of cars, specifically the fuel they use and the greenhouse gases they release. He is studying bioethanol, an alternative fuel to reduce the fossil fuels we use.
Have you ever had a fever and the only thing you can do is to drink more water and have some sleep? That's uncomfortable, right? The fact is, our Earth is suffering from the terrible fever, which is caused by the greenhouse effect. I'm Yu Hao Hong, and you can just call me Ronnie, and I got my bachelor's and master's degrees in food science at the National Taiwan Ocean University. And now to focus on the biofuel research, I'm pursuing my PhD degree in bioresource and food engineering at the University of Alberta. So in this video, I'm going to share my research, but before that, let me tell you a story. Greenhouse gases like carbon dioxide are released into the atmosphere from burning of fossil fuels and other activities. Greenhouse gas can trap heat. As the population and human activity increase, we release more greenhouse gases. For example, we need heat for cooking, we need electricity to charge our phone, we also need fuel for our transportation. Otherwise, getting to school, work, or other outside activity may be a lot harder. These activities are often using fossil fuel, releasing greenhouse gases, and are one of the reasons causing fever on Earth. So it is important for us to find an alternative fuel to reduce how much fossil fuel we use and carbon dioxide emission. So this is my research is about biofuel. Biofuels are a fuel generated from biomass. such as plant, animal waste, or other agricultural materials. When biofuel is burned, it also releases carbon dioxide, like fossil fuel. However, the releasing carbon dioxide from biofuel, it can be recycled by the biomass. In other words, there's a balance between releasing and capturing. For fossil fuel, they are releasing carbon dioxide from millions of years ago, so it doesn't balance within a short period. Also, compared to fossil fuel, biofuel is a renewable and sustainable fuel. It won't run out as long as you use a biomass that keeps getting produced. One of the most popularly created biofuels is bioethanol, which is my focus. From biomass to bioethanol, there are many steps in the production process. First, the biomass is converted into small units like sugar. And then, microorganisms use those units or sugars to produce ethanol. The microorganisms are like a factory that use a process called fermentation to produce a desired product. In my project, ethanol is my desired product. And this is a so cool process. In our daily life, beer and wine are the famous product made from fermentation. Finally, in the processing, ethanol is recovered and purified. We can add this bioethanol to gasoline, with the partial replacement reducing the total carbon dioxide produced. Based on its benefit, many researchers and industry are studying on the bioethanol production. In the research group I am working with, we also want to find a way to boost the ethanol productivity and profit too. And my research is focusing on increasing the amount of bioethanol within a short time during the fermentation step. If we want to get higher amount of ethanol in the fermentation step, we need to provide more and more sugar to the microorganism. In my research, I use yeast. However, giving too much sugar to the yeast at once would slow the rate of eating and even damage the cell. To be able to study this, one of the important steps in my research will be to find an easy and effective way to monitor cells growth, which is related to ethanol production. For instance, imagine you really like steak and you are in a room surrounded by thousands of steak, and now you are expected to eat them all just in one meal. Just imagine that. You may be so overwhelmed that lose your appetite for steak before you even start. The same thing would happen to yeast if we provide too much sugar. Therefore, it is important to figure out the ideal feeding strategy. That is, how much sugar can be provided and how often it can be fed during fermentation to produce the ethanol of high quality and quickly. To be able to study this, one of the important steps in my research will be to find an easy and effective way to monitor cells growth, which is related to ethanol production. If we can monitor cells growth, it will let us know if the feeding strategies that I am testing are working. In addition, I am going to focus on reducing the time required for fermentation, which can improve the overall efficiency of bioethanol production. I hope this research can bring an idea to stimulate bioethanol production and increase the chance for it to be adopted into the ethanol industry commercially. So to wrap it up, to lower the carbon dioxide emission and relieve fever for Earth, we need to find an alternative fuel to fulfill our human demand. And bioethanol is a promising biofuel used in transportation. Therefore, by improving the efficiency of ethanol production, we expect to acquire higher ethanol productivity and ethanol yield than traditional method. thank you so much for watching this video. I hope you like it, and don't forget to subscribe this channel to get more information about energy. So see you next time. Bye.
Thank you for joining us to learn about cars. Are you feeling inspired to design a new car or find new ways to reduce their environmental impact? Make sure to subscribe to Future Energy Systems YouTube channel so you don't miss any of our exciting content, and check out the links below. There's so much to learn as we explore our energy future.